Okay, so now in this section we are going to learn a new nonlinear differential equation. So this differential equation is where you have a tank, okay, and from the bottom of the tank you have a leak, or you have an opening and you leak fluid from there. Okay, so let's say h is the height of the tank and you have a fluid, and let's say AW is the area of the top layer of the tank, and let's say A sub h is the area of the cross-sectional area of the opening of the tank, and let's say the speed that the fluid goes out, exit from the tank is simple V, and the volume of the tank as capital V. All right, so if we have another proportional constant K which depends on the viscosity of the fluid, but let's assume simple K to be 1. So using the basic laws, we can say the rate of change of volume of the differential equation is negative because the water exits, the fluid exit, A sub h, the cross-sectional area, times the speed that the fluid exit from the cross-sectional opening. Okay, all right, so this is the rate of change of volume, not the speed. Okay, speed is here. And now using the conservation of energy, kinetic energy at this level and the state energy should be same, right? Okay, so we can use the conservation of energy, and half mv square is equal to mgh. From here we can find the speed v as square root of gh 2gh. Okay, so when we can replace the speed by minus a sub h times square root of 2 times g times h. G is the gravity. Okay, all right, now we have a formula for differential equation for rate of change of volume. But actually think what is volume is. Volume is actually the upper layer cross-sectional area times the height, right? AW times h. Now what is rate of change of volume? dV over dt is, if you differentiate the right hand side, AW is a constant, that's the area, h is changing because the fluid is exiting, so the height is changing, so dV over dt is AW times dH over dt, right? So we can take this AW times dH over dt and put it on the left hand side of the differential equation. We get negative a sub h square root of 2gh. Now we can divide by AW and we can get this new differential equation, which is nonlinear, and this differential equation is for rate of change of height of the tank. This is nonlinear because on the right hand side of the differential equation, dependent variable h is square root of h. It's not degree 1, right? So it's nonlinear. And then this is an autonomous differential equation, right? Because on the right hand side you don't see the independent variable t explicitly, you can see only dependent variable. Let's look at an example. Example says you have a cubical tank and length, width and height is 10 feet, and you have a circular hole, and the radius of the circular hole, the opening is 6 inches and gravity is 32, and they say the differential equation is actually dH over dt constant. The constant that I assumed as 1 is not 1 here, they say it's c, so c a sub h square root 2gh over AW, and don't forget the negative. This is the differential equation. And they say that, okay, yeah, we have a circular opening and this is a cubical tank, that means length, width and height are same, it's 10 feet. Okay, let's write the differential equation. dH over dt minus c, they say 0.6, okay, 0.6. A sub h is the area of the circular hole, the opening, right? So it's inches, but all the others are given from feet, like gravity. So we have to convert 6 inches to feet. So if 6 inches means 0.5 feet, the radius is 0.5, so the area A sub h is pi r square, right? 0.5 square. So A sub h is pi 0.5 square over AW is the area of the upper layer. So upper layer is actually a square. Length is 10, width is 10. So 10 times 10, 100. So that's in its feet. So good. So 100 times square root of 2 times G. G is 32. So 32 times 2 is 64. 64 H. H is the variable. Now I can simplify this right hand side. Okay. I can write negative 0.6 is 6 over 10. So you can bring another 10 down. So 6 over 1000 pi 0.5 square root of 64h. And then 0.5 means half. Half square is 1 over 4. So it's negative 6 pi over 4000 square root of 64h. Square root of 64 is 8. Okay, so that means 8 times 6 is negative 48 pi square root of h over 4000 dh over dt. So we can cancel 48 and 4000 by 16. So there are 3 16s. For 400 there are 50. So you get negative 3 pi square root of h over 500. So this is the differential equation. Okay, so if we look at this differential equation, that is how we build up it. So solving this differential equation, that's an exercise in your next quiz. But let me give you a hint. How can we solve this? This is a first order linear differential, non-linear differential equation. Well, we can separate variables, right? We can bring the square root h to the left, keep negative 3 pi over 500 on the right, bring dt to the other side and integrate both sides. Okay, so then we can solve this differential equation, and that's the exercise in the next quiz. Okay, all right, thank you then.